Something that has become very prominent lately are so-called large language models and the artificial intelligence chatbots that are built on top of them. In this video, I will explain how these systems work. This will be crucial if we want to understand what they can do and also what they can't do, which will be the topic of the next video. To understand how AI chatbots like ChatGPT or Google Bard operate, it helps to think of them as being created in 3 steps. In the first step, a large language model, or LLM, is trained on a dataset to become good at predicting text. In the second step, this LLM which predicts text is turned into a program that generates text. And in the third step, this text-generating program is hidden inside a chat interface where the user can ask questions and get answers. To understand what is going on when we are having a chat with the computer, we need to pull away the chatbot mask and see what's going on underneath. So, first step. A large language model is trained on a dataset, which is a very large database of texts, to become as good as possible at text prediction. What is text prediction? Well, suppose that I say to be or not to. It's easy to predict what my next word will be, to be or not to be. Of course, most sentences can be continued in multiple ways. Suppose that I say, oh, I haven't seen him yet, but I will meet him on, well, I will meet him on Monday maybe, Tuesday, Saturday. Our best prediction here might be probabilistic. There is about a 1 in 7 chance for each day of the week. And of course, in many cases, the possibilities are even more wide open. If I start a sentence with the words, yesterday well, that could be a lot of things. A large language model is a computer program that has been trained to perform such text prediction tasks really well. This training involves giving the model many texts, usually stolen, copied from the internet, and having it make billions of predictions. Correct predictions reinforce certain pathways in the model, while incorrect predictions weaken those pathways. And the end result is an extremely complex black box model that is quite good at predicting the next word in a text. Time for the second step, turning text prediction into text generation. Well, that's actually quite easy. You just give the LLM some text to start with. This is called the prompt. And then you tell it to predict the next word, to add that predicted word to the text, to predict the next word after that, and so on. So while the LLM is technically predicting words, the result is that it writes a new text. To make this work well, you've got to fine-tune the process a little bit. For instance, you've got to tell the LLM not to take the most obvious word all the time, because that would lead to really boring texts. But this is basically how it works. And these generated texts can look pretty good. If you prompt the LLM with the little snippet that says, Columbus discovered America in, then based on all the texts it has seen, it will predict that the next word is 1492. And so it will finish the text in a way that gives the impression that it knows about history. Even more impressively, when you prompt the LLM with, it may be misleading to say that Columbus discovered America because, then it will usually produce a cogent story about Native Americans maybe, or Vikings. It can do that because it has been trained on texts about these topics. It's important to note that this has nothing to do with truth. If you prompt the LLM with, for breakfast this morning I had, it's going to predict something. As a test, I put this prompt in an LLM called Aero Chronos 33 billion, and I got the following text. For breakfast this morning I had 2 slices of Ezekiel bread toasted with some peanut butter and jelly, a glass of OJ and a cup of coffee. It was easy to make and very filling. I feel much better today, although my stomach is still a little sensitive. My appetite is back and I feel ready to tackle the day. Well, there's nothing true about it. The program was just doing what it was asked to do. Complete my prompt in a plausible way. Truth has nothing to do with it. This is how LLMs work. Now, if you've played around with something like ChatGPT, you may be thinking, wait, that's not what it's like to interact with these AI systems at all. And that's right. Which brings us to step number 3, hiding the large language model behind a chat interface. When you interact with something like ChatGPT, you ask questions, and it gives you answers to those questions. So it really looks like a program that has a lot of knowledge and that tries to tell you the truth. But that is an illusion. What you are interacting with is a large language model doing text prediction. Now, how do you make a text prediction program generate texts that are helpful and accurate answers to questions posed by a human? Well, here's what you do. You give it a text that starts like this. What follows is a conversation between a human user and a chatbot. The user asks questions and the chatbot gives answers. The chatbot is helpful and accurate. Its answers are usually about 200 words long, etc., etc. When you have a session with ChatGPT, you only see your questions and its answers. But there's also a lot of text involved that you don't see, but that the underlying LLM does see. And that hidden text in effect tells the LLM to predict what would happen next in a text about a human and a helpful chatbot. And that's why ChatGPT sounds like a helpful chatbot. It is predicting what a helpful chatbot would sound like. So let's get that straight. The LLM is not really answering your questions. It is predicting what a certain kind of text would look like. And it's important to see that that is not the same thing at all. Suppose I ask you whether the Earth is flat or round. In order to answer that question, you have to think about what you believe and about your evidence, and then you tell me what you believe based on your evidence. But if I ask you to predict what an answer to that question may look like, you have to do something very different. It's not about what you believe, it's about how people in general talk about this. It's about what answers you would find in the corpus of texts that you were trained on. If there are a lot of flat earthers on the internet, it becomes more plausible that a random text might claim that the Earth is flat. So, if these chatbots frequently give correct answers, it's because they've been trained on a corpus that is often accurate. But accuracy, truth, reasons, arguments, that's just not part of how these programs work. When they say something false, they haven't made a mistake. They've just done a prediction. And of course it's perfectly correct to predict that texts sometimes say false things. When these chatbots make detailed claims that have no basis in fact at all, people often complain that they are making things up. But that's a mistaken complaint. These programs are just doing what they've been built to do. They write texts that look like real texts. What does that mean for using them? And why do so many people make these mistaken complaints? Well, that's what we'll discuss in the next video.